Hey, hi everyone. Today I just have a little a video for you guys. It's only about debunking 7 data science COVID myths. It's really from a paper I read recently, and it's a little article by this guy called Evan Ginn. It's making its rounds. It's called Evidence Over Hysteria. And really, Aaron Ginn, just to give a bit of background, he's a marketer, someone who's done a lot of viral marketing and stuff like that. And the article he writes is compelling, it's interesting, and it also contains a lot of interesting data science flaws or myths. And so what I'd like to do here with the next 5-10 minutes, just to go and perhaps help you understand where he's gone wrong, because it's not always obvious where the mistakes are happening. So the article is on Zero Hedge. That's the link there. It's been actually banned from Medium, surprisingly. And so he's actually moved the article originally from Medium into Zero Hedge. Okay, so the first myth that he gives out is that he says that the total cases are the wrong metric to use to actually determine the severity of the virus itself. So when he says, look at all those red circles that you see on the map, they're getting bigger and bigger, but they only represent the total cases. So his argument is this virus is actually over 4 months old. So actually, perhaps a lot of these cases aren't active anymore. And the second point he makes is that perhaps we need to look instead at ratios and percentages and conversion rates and growth rates to actually determine severity of the COVID-19 outbreaks. Well, this is a myth. And the first reason is because exponential growth of any kind is always alarming. And it's an indication that something is going on, which it's worrying, right? Well, the first thing that exponential growth shows you or tells you is that everyone will catch the disease very quickly. And this is the important part, that a lot of people, I'm saying everyone, but what I mean is a lot of people, and quickly is the other operative word as well, because exponential growth, well, it's exponential, right? The second point is that even a small percentage, I'm just taking 1% as a representative number, 1% of everyone is still a lot of people to put in. So a small percentage of a lot of people is still a lot of people, right? And what that means is that it will actually, if it happens quickly, it would actually put hospitals out of capacity. Now, I'm sure you've heard this particular argument before. It's actually to do with flattening the curve, which has been put out by the CDC. The other point is that from a data science point of view, the differential of any exponential or power law still remains an exponential or power law, right? So what that means is that the total amount of remaining cases will also perhaps, if you see the total cases going up exponentially, then it means that the remaining or cases which are cured will also be going up exponentially. Now, myth number 2 is that, well, perhaps we ought to be looking at per capita numbers rather than the absolute numbers from each country. So on the right-hand panel, you can see this very famous, I'm sure you've seen it before, graph where they plot the trajectories of different countries, how the total cases grow over the countries. So what Aaron's argument is that, none of these charts are on a per capita basis, and that it treats every country as a single entity. And because of that, you fail to see what's happening or what's going on. His argument is that we ought to divide by the size of the country itself. Well, that's not really the case. The first problem is, well, the first problem with his argument is that the plots are always logarithmic. And logarithmic plots really focus on the slope of the graph. And because the slope of the graph shows you growth, okay? So the steeper the slope, obviously, the more higher the growth, right? And what these graphs additionally do is that they are all shifted by time, so that they start at the onset of the first 100 cases. So as soon as you get 100 cases in a certain country is when you start the number of days, which is the horizontal axis. So what that does is to actually remove dependencies on any kind of size of the country. Let me show you what I mean by this. So let's assume we have something which is growing exponentially, right? So that's the form. that you get. Now, if you log it, then it becomes linear in t, which is time, and log m is the growth factor. So the slope of the graph on a log plot would be m. Now, if you have, let's say, t naught, you get 100 cases, then of course you get this relationship using the log equation. So if you shift the graph by t naught, then this is the shifted formula, which is y tick. And the log of y tick is this new formula. And if you just do a simple replacement, what you get is that the log of y tick is equal to t log m plus 2. So you can see clearly that there is no dependence on the normalizing factor a. So it doesn't matter if you're assuming exponential growth, then dividing by, let's say, the country size will give you the same relationship. So of course, it assumes exponential growth. Now, the thing is that these graphs that you've seen so far already show exponential growth, which means that this manipulation is valid. Now, the other point he makes is that COVID-19 is spreading, but probably not accelerating. And as proof, he shows two graphs. This is one of them, of a few countries, and where over the last, let's say in this case, 30 days, you see a decrease in day-to-day growth rate. So his statement is that daily growth rates have declined over time, regardless of particular policy solutions. Okay, now this is a very dangerous assumption because it's easily debunked. The first thing is that the China and Iran numbers are very suspect. Iran is probably undersampling because they don't have the equipment or people to actually do it. And China is probably underreporting these numbers, as they already probably have early on in the outbreak. South Korea, which is the other country on this graph, has strong control measures. And the last country, the US, from the graph alone, shows you about a 20 to 30% growth rate day to day. That's huge. And of course, the fact that the growth rate really hasn't changed for a lot of these countries, or more for the other countries, is from the first graph that you saw, which is exponential growth, right? So because you have exponential growth, what it means is that you get sustained day-to-day growth. It's not really decreasing, except for a few countries like South Korea, which have managed to flatten the curve because they have got very strong social controls. Myth number 4 is that viruses follow a common pattern, what he calls a bell curve. Now, we all know what a bell curve is. And his point is that viruses don't grow infinitely forever and ever. And that's true, because it would be, the most you can grow is the size of the population you can infect. And the second point he makes is that, as with most things in life, in nature, viruses follow a common pattern, which is a bell curve. And he calls up something called Farr's law. Well, to be honest, this myth is also pretty easy to debunk. The first thing is that the bell curve is most likely due to lowering the probability of transmission through strong preventive measures. Now, removing these factors would likely cause the virus to re-emerge or resurge. And I think in this case, what he's done is to confuse cause and effect. The cause is the preventive measures put in by the various countries like China and South Korea and Iran and so on. So the bell curve is really a effect of that cause. Now, it is possible that in the longer term, we actually acquire herd immunity, but this is still unproven. We don't know if that's possible. Or perhaps we get a vaccine. Again, this has not been completely proven yet, although people are working on a vaccine. The third point is that the virus mutates, making it less deadly. Now, this is possible. We've seen it with SARS in the wild, which mutated to the point that perhaps it wasn't so dangerous anymore. But again, with this virus, there's no guarantee that will happen. The last possibility, of course, is there's widespread effective treatment for the virus. And we've seen some positive signs of that. But again, this won't affect the growth because people can still infect each other. If there's no social distancing, there's no there's no other things, that's no social controls in place. Now, the last myth, myth number 5. Myth number 5 is, in flattening the curve, both scenarios have similar COVID-19 cases. Now, this is really an easy myth to debunk. Let's have a simple thought experiment. Suppose you got one person with 9 friends. The one person has the virus. If they keep apart, he's the only one who gets the virus. But if they go for lunch together or dinner together, then obviously more of them will get the virus. So it's not true that flattening the curve through social distancing means that you have the same amount of infected cases as without. It's a fallacy. Now, myth number 6, in the article, he mentions that there is actually a low probability of catching COVID-19. And he estimates it at 1 to 5%, depending on various papers. Also, there's a strong but unknown viral effect. And, you know, he sets out to prove that asymptomatic spread isn't important. It's not really significant. And that really only 93% of the people, 93% of the people who think they are positive really are not. Well, my answer to this is that there's already very clear measure of actual cases, and we see that in the number of actual cases, we see exponential growth. That's why on the log plots, those numbers are a straight line. So if you look at China, Iran, and Italy, you've got really exponential growth unless you have very strong measures put in place to prevent the spread of the virus. And that this measured data makes all the other estimates really irrelevant. So my advice is, in this situation, use your own eyes, look at the news, and rely on your own intuition rather than convoluted, data sciencey type reasoning, because it can actually, make you lose the forest for the trees. Now, the last myth, well, he's got a few. The first one is that COVID-19 will likely burn off in the summer. Well, if you look at Singapore, in the first few weeks, the growth was quadratic. And Singapore is a hot, it's a humid climate, which is supposed to be bad for viruses. But yet, without the strong interventions put in Singapore, we probably have seen at least power law type growths, quadratic or worse. The other point he makes is that 1% of the cases will be severe, so don't worry about it. Again, it's all about how fast these 1% of cases happen. So with exponential growth, even a 1%, because it's so quick, it overwhelms the medical services, and this is all about flattening the curve. And lastly, he talks about declining fatality rate. This part is true. It is true that the fatality rates have declined, and it's a result mainly of better testing. But again, it also depends on functional medical services. Again, like in Italy, if the medical services are overwhelmed, then you'd probably get much higher fatality rates. So some takeaways. The first one is trust your eyes, especially if they disagree with your conclusions. Get more honest feedback. Whenever you write an article about data science, get honest feedback from people who oppose your view. Also be aware of the social impact of what you write, what you do, or what you say. This article was actually widely publicized for quite a while on Twitter and other places, on Medium, for example, right? And it still lives on in Twitter through links. And it's actually caused people to think, it's okay, just go out and, circumvent social distancing. But the last thing I'd like to say is that censoring dissenting views, like how Medium and Twitter have done, isn't helpful. Free speech is very important. And instead of countering these fallacies through censorship and blocking people, the better method would be to debunk. Okay, that's all I have for you today. Thanks. Bye.